Natalie Wickham and Jenny Bryan. Um, and I want to talk about and emphasize kind of workflow things. Things like sound and name, but things like keyboard shortcuts and building muscle memory for different things that you are doing as you're developing a package. So you don't have to think about the structure and the mechanics of the package, but you can focus on the code that you're writing to make the best package you want. I was trying to think of a way to structure this talk without it being just kind of a disorganized grab bag of tips. And I was going to sort of live code building a package, but I didn't think that there would be time. And so I'm going to just walk through the general process of developing a package and highlight some key productivity enhancers as we go along. So starting with the tools that we use, and that these are the sort of tools that I've chosen to use, and a huge proportion of our developers are using. And they're designed to work together to create an efficient package development workflow. Use this is kind of the star of the show. We'll be talking about use this a lot. It provides most of the main workflow tools. DevTools is kind of the umbrella meta package that houses a lot of functionality for creating, building, loading, installing, checking, doing all these sort of mechanical things with the package that you're building. And importantly, DevTools exposes all of use this functionality, so that when we load DevTools, we get use this along for free. The other package is Roxygen 2 for documentation, test that for testing, and package down for building package websites. And then sort of, I think that RStudio is still currently the best IDE for package development in R. I know it's kind of not as modern as some IDEs. It's been around a while now. I love Visual Studio Code, which I think a lot of people are using. I use it for everything that's non-R. But RStudio is hard to beat with its great integration with DevTools and sort of related packages. And they've kind of been designed hand in hand to create nice workflows. Things like keyboard shortcuts built in and really nice debugging features. So the first productivity enhancer is to have DevTools in your environment at all times when you're in there. So you don't have to do library DevTools or anything. Whenever you sit down to work on your package, DevTools is there as your friend. In general, it's bad practice to attach packages in your R profile file because it can break reproducibility. Most of us try to avoid this. But by using this use DevTools function, we can put some code in our profile file that ensures that DevTools will load automatically when we start R. And this is a bit different than putting other packages in your R profile, because DevTools and test that we rarely actually use the code that their functions in scripts or in packages code. They're kind of like the tools that we use to build packages. So having them out of the toolbox and on our workbench all the time makes it a lot easier to be productive. So putting this little bit of snippet of code in your R profile using the use DevTools package is just a way to make sure that it's always available. I also put test that in there because I often find myself fiddling directly with tests while I'm working on them. And so it's helpful to have that package attached. Just want to highlight sort of the first keyboard shortcut that I think is one of the most important ones, and that's restarting R. When I'm developing a package, I'm restarting R. I use a Mac, so it's Command-Shift-0. I do it all the time because you don't want to, you're developing things and you might end up with cruft temporary objects and things like that in your environment that might make your package behave in unexpected ways when you're working on it. So restarting R all the time so you've always got a clean slate is a really, really good practice. Okay, so we're going to create a package sort of from scratch. We're not going to do it now, but that's the part I want to talk about right now. One thing that's really nice to do is to avoid some of the pain of package setup by, again, editing that R profile file and putting some default values that are going to go in your package description file. So the description file is the file that sort of contains most of the metadata about your package. It's got the title, it'll have the description about your package. It lists all of the dependencies, and sort of pertinent to this slide here is the information about the authors and the licensing of the package. So for mine, I have my name and email address, role, and then if you have an ORCID, it's nice to put that in a comment field. And so I won't belabor this too much because it's going to be different for everybody. You can put in a different license sort of default as well, but there's a great vignette on the Use This webpage for sort of setting up Use This, including how to set up your default description values in your R profile. And so what this means is that when you type create package, which is the function in Use This, it not only sets up the structure of your package by creating a directory that holds all of the main skeleton of a new package, it populates that new description file with those template pieces that you stored in your R profile. So it's really helpful to get going on a new package right away. And just another word about this create package function. You provided a path to a directory that probably doesn't exist yet, and the final name in that path is going to be the name of your package. It'll restart RStudio in that session. And like I said, populates the basic package skeleton. So create packages, obviously you're only going to use it once probably when you're making a package, but it's an important one to help you get started on the right foot. Quick word about licensing. It's a big topic. There are a lot of different open source licenses. But there are helper functions in Use This to help add each one the right way. CRAN is picky about how different licenses are specified in your description file and then what goes in the license file. So you can sort of add these things manually, but it's easy to get wrong. And so these helper functions like use MIT license, use Apache license, those are all, they set it up properly for you. They fill out the description file properly and they put the right license file in the right place for you. So the use license helpers are really useful for that. So this, you've probably guessed, is like a bit of an advertisement for Use This, but I think this is a bit of a sidebar, but when I worked with Jenny Bryan at Posit, and I was working on Use This with her, I discovered a whole bunch of gems in there that I didn't know existed, but I also realized that all of these functions are really mindfully put together to enable really efficient workflows. And so if you can kind of embrace that ethos of using these functions to help you be productive, it can really, it can really sort of push your development forward. So there's going to be a lot of use _something as we keep talking. Case in point, you can put your code under version control and put it on GitHub with just 2 calls to use Git and use GitHub. And obviously it's a good idea to get your version control set up early in your package development process. These 2 functions are useful for that. Okay, so you've got your package structure set up. You've chosen a license, you've got GitHub, and so you want to start writing R code. You want to put some functions in your package. All function code in a R package goes in the R directory, but there's a lot of different ways that you can organize that code. And if it's going to be a big package, there could be a lot of it. And so there's some kind of good conventions to use. I know when I first started, I would have like up file functions.r, and it would just end up being like thousands of lines long, and it would be really hard to find what I wanted in there. But a really good way to help yourself navigate your own code is to have the files in that R directory named after the functions that they contain. And sometimes it'll be a family of functions. It might be, 3 or 4 functions. But the file name should evoke what's going to be in that file. It seems intuitive, but it's not always the case. This useR function is just a really quick shortcut to open up a new file in your R directory and save it under that name, and then open it for editing. So it's handy for that. And then the definition of your function or functions will go in that file. And then, when you're developing a package, you'll have a bunch of user exposed functions that a user is going to be able to use from your package. But you're probably going to have a bunch of little helper functions that are internal to the package that a user wouldn't use. They're not exported to the user. And those helper functions should usually go in the same file as the exported function. And I always have the exported function at the top of the file, so that when you open the file, you can see what this file is for. Okay, yes, it's producing this this function, and then below that are all the helper functions that go along with it. Yeah. So you've got a couple of functions going, and then I think this load all is probably the most important tool in the package developer's toolbox. And probably if you're going to memorize one keyboard shortcut, it's Control-Shift-L if you're on Windows and Linux, or Command-Shift-L on Mac. Because what this does is it basically short circuits the whole process of installing a package, typing library, and getting that package available in your environment. And it just makes your whole package available to interact with. And so it basically simulates that whole process, and it makes all of the functions in your package immediately available to use. And this allows really fast iteration and fast cycling of editing your code, playing with those functions, realizing that you need to change something, edit the code, change something, and so on. And so that quick iteration there is really important. And the load all with these keyboard shortcuts can really enable that. So I've got this workflow diagram here that we're going to kind of build up as we go. And so this is just the first piece of the package development workflow, and it's really just edit your code, load all, play with your code, edit your code, load all, play with your code. And that keyboard shortcut helps with that workflow. So once you've got sort of hopefully your first function, but sort of any number of functions working mostly as you think they should in your package, then it's time to check and make sure your package is sort of built properly. And the tool that we use for that is R command check, which is a command line tool, but it's a bit cumbersome to use. You have to leave R, go to your terminal, build your package, run R command check on the built package. There's a keyboard shortcut just called check, or sort of this function that we can use in DevTools called check, and it does that from within R, and it does it really quickly and easily. So that enables checking early and checking often. So you can, as you work on your package, you should be running check very frequently so that you can catch problems early. When you run R command check, there's kind of three messages that you'll get back. You'll get a count of errors, a count of warnings, and a count of notes. Errors are severe problems. It means your package is broken. You have to fix those. Warnings are sort of a little bit less of a showstopper, but they're problems that you should fix. And if you're planning on submitting your package to CRAN, you absolutely must fix. So any warnings will be a no-go. And notes are generally milder. Usually mild problems are sometimes just an observation. But if you're going to submit to CRAN, trying to get all three, no errors, no warnings, no notes, is a good practice. And like I say, if you run check really frequently, these things won't build up over time, and you won't have 20 issues to deal with when you're ready to submit or share your package. So that just adds a sort of another step in our workflow. We've got the workflow of editing, loading, running our code, seeing that it works properly, and then running check. And the keyboard shortcut for check is Control or Command Shift E, depending on if you're Windows, Linux, or Mac. And like I said, like this cycle you should be able to do pretty quickly and frequently. So if we've got some packages, we've built some functions. We are working on the cycle of developing those functions and checking the package. We also have to build documentation for our users. We're all familiar with what function documentation looks like from a user perspective. You type > function name, and your help pane pops open, and there will be like a nice description of the package, or sorry, of the function. These are generated from these .rd files that are in the man directory. They're horrible to look at and to work with and to type. They're like very much like LaTeX, but not quite. And so we want to avoid that like at all possible. And so that's where the Roxygen 2 package comes in. It helps us not have to write those .rd files directly, but we can write in a much nicer format. And so the documentation using Roxygen 2 comes in the form of special comments that go above the function definition. And so here's like a very simple function, adds two numbers together. It's in our .r directory, and there's a list of sort of those special comments prefaced by the normal comment sign, the hashtag, and then a single quote. And they go in sort of a predictable order of title, description, function parameters, denoted by the @param tag, the return value, what is this function giving back to the user, the export tag. This one just determines whether or not this function is going to be exported to the user. Is it going to be a user-facing function, or is it an internal function? And then hopefully some examples. The Roxygen 2 is a very deep package, so I'm not going to get into it fully, but sort of just as an overview, writing like this is a lot nicer than writing those .rd files. And another really good benefit of this, and this is more of a workflow thing than a pane of writing thing, is that it keeps your documentation with your code. And so that when you're writing your function and you're realizing how it's going to operate to the user, the documentation is right there with it, and so you can write the two hand in hand together. And that's a really important feature. And then we use the document function. New keyboard shortcut again, Control-Shift-D. Yeah, and it converts those Roxygen comments into these .rd files. And so we never have to touch those .rd files. So I kind of went through all of this already, but in short, you go to the definition of your function, you put your cursor in it, you can insert the Roxygen skeleton, and it's really nice. There's a actually maybe I'll flip to RStudio quickly just to show where it is. Where is RStudio? All right. Pull up a function and you click on edit, nope, code, insert Roxygen skeleton, and it'll put in a block of code for you to fill in, sort of a template. There is a keyboard shortcut, Control-Alt-Shift-R, which is like a little bit more of a dance with your fingers, and it takes a little bit longer to commit to memory. But putting that skeleton in there gives you the framework for filling in those documentation pieces. Fill those in, run document, And then you can type my function or the function name and get that help pane up. And then usually after you've written the documentation, it's a really good idea to run check, because documentation is a common source for our command check errors. It's kind of easy to get a little bit wrong, whether it's undocumented parameters or undocumented return values or more complicated things. So running check when you document is a really good idea. And then in general, I've heard this question about, should we commit rendered documentation to our GitHub repositories? Because normally when we're writing a script for data analysis, we don't commit rendered outputs, right? We don't commit our plots. We don't commit the rendered markdown documents, because it's sort of a barrier to reproducibility. But we do commit render documentation files to GitHub. There's a few reasons for that. Roxygen comments aren't officially part of a package spec, like according to the how we build packages. They're just a tool that helps us build those .rd files. So if we push our stuff to GitHub without those .rd files, it's not actually a complete package. If we're asking users to install our package from GitHub and those .rd files aren't there, the documentation won't work for them. It probably won't even install. And if we're using continuous integration, which I'll talk about a little bit later, it will fail because our command check needs those documentation files. So even though it's like not considered best practices in most cases to commit rendered things, the documentation files are a different beast. Okay, the other thing that Roxygen 2 helps us manage is our namespace file, which is a bit of a sort of a strange beast. The namespace file lives in the root of your R package directory, and it basically lists objects that are both exported from your package to be used by package users, and it lists objects that your package is importing to be used internally into your package. The nice thing about Roxygen 2 is that we don't really need to worry about it. Using those tags that in our Roxygen blocks, document will generate the namespace for us, and you should never need to edit it manually. I saw a post this morning of someone who was fighting with the namespace file, and their solution was actually a pretty common practice: is delete the thing and then rerun document, and it'll regenerate it. And so namespace file is there. It can get complicated depending on how your package is built, but Roxygen 2 manages it for us for the most part, and so that's kind of nice. Okay, so we've got a new workflow diagram here, but this one's around documentation now. And so now we can edit our Roxygen comments, run document, hopefully committing that keyboard shortcut to memory, Control-Shift-D. And then we can preview our function documentation right away with that question mark function name. And then we will want to run check on that to make sure that our documentation that we've generated is okay. And so we can start to combine these workflows now and make it sort of more of a holistic thing. So we're editing our code, we're hitting Control-Shift-L to load the code. We run the code, we probably need to edit it. As we're editing the code, we realize, oh, we've changed how our function is going to be seen by users. We need to edit our documentation. So we'll edit those Roxygen comments. We'll run document, we'll preview documentation. And these kind of cycles kind of go together and are brought together by running check frequently. So we've built a package, we've made some functions, we're sort of understanding the structure of that. We've worked with some documentation. And then we should probably make sure that our code is doing what we think it does. Check mostly makes sure our package is structured properly, but it's not actually at this point running any code. So we want to do some formal testing. So at this point, this has been our testing. We write our functions, we load the code, we load the functions, we play with it. We're like, yeah, that works pretty well. Move on. But the problem with this approach is that if you come back to that in a few months' time, you've probably forgotten some of those informal tests that you ran the first time around, and it makes it really easy to break code that used to work. And so that's where sort of formal automated testing comes in. And TestStat is sort of kind of the de facto standard out there. I know there are competitors, but TestStat is really heavily used across our developer community. So that's what I'm going to talk about. Automated testing basically confirms that your code does what you intended it to do. It returns what you expect them to do in the scenarios that you expect it. They fail under certain scenarios in ways that you expect them to fail. And hopefully they deal somewhat elegantly with edge cases that users might throw at them. And so there can be quite a wide space of things to test in a function when you think about all of those things that you might want to look at. And there's some really big benefits. So you generally create fewer bugs. When you're writing formal tests, it can force you into a space of anticipating unexpected usage, and sort of seeing what happens when users might use your code, your functions in unexpected ways. And if you write new tests when you add a new feature, you can help prevent bugs from being created in the first place because you can proactively address those pesky edge cases. It helps you write better code. When you write your code with testing in mind, it's hard to demonstrate here, but you'll quickly learn that poorly designed code is actually really difficult to test. If you have huge monolithic functions that do a million things, writing tests for that is really hard. And so by writing tests against your functions, you'll see that sort of smaller, more modular functions are easier to test. And so using tests can force you to write better code, better designed code. You can use tests as a call to action when fixing bugs. So if someone submits a bug report and your function is not behaving the way you expect, you can actually use that bug report as a new test. Distill it down into something simple as a new test that your current code fails on. But that code that the user submitted that's generating what they didn't expect, you can edit your code until that test passes. It's test-driven development to a certain extent, but it's kind of like bug test-driven development, maybe. And so tests are really good to ensure that you fix those bugs. And I think one of the biggest ones is robust code. And I say future-proof here, but I almost mean like refactoring proof. If you decide that you've designed the internals of your package in a funny way and you need to change it, having a whole suite of tests that ensure that your functions are behaving the way that you expect them to, you can go and mess around with your functions. And if those tests are still passing, you know that you've only changed the internal structure of those functions and maybe made them more efficient, but you haven't changed the user experience of using those functions. So those tests are kind of like they're kind of like your benchmark of the package functioning itself. Again, we've got helpers to set up our test infrastructure. Very simply use TestStat. We'll set up test infrastructure in your package. And then we can use the use test function to create a test file. And this kind of harks back to what I was talking about, organizing your R files. And it's good practice to organize your test files so that every test file mirrors the file in your R directory that it's testing against, so that you can easily navigate between your function code and your test code. And a nice way to do this is to, when you've got a file open in your editor, and it's got your function code in it, and you want to write tests for that function. If you just type use test with no arguments, it will create a new test file that's named to mirror that function file. And so here is a sort of an overview of a package directory. So we've got the root level files of description, license, namespace. The R directory has a hello world.r file in it. And then the test that directory has a test hello world.r. And it's kind of nice if you can map those one-to-one as you develop, because then it's easy to keep track of what tests are attached to what functions. And so once you've got some tests written, you run them with just test or Control-Shift-T, Command-Shift-T if you're on a Mac. And so another really useful keyboard shortcut, which you should run frequently. Pretty much every time you edit a function, run the tests. And so our workflow diagram is getting more complicated, but it's also like really integrated. So we're writing our code to create our functions. We're running load all and running it and playing with it. But now we're writing some tests, and we're running tests on those tests to test the functions. That might cause us to go back and edit our code a little bit more, play with a little bit more, see that it's working, maybe write some more tests, but for sure test it again, and then run check. And then we can sort of like add this together with our documentation workflow, right? So we're writing our code, we're writing our tests, we're writing our documentation, and we're using these helper functions of load all, test, and document with their keyboard shortcuts to sort of like iterate. We can iterate really quickly on this. Like it seems like an overwhelming diagram, but once you get really these 3 or 4 keyboard shortcuts down, the iteration cycles can be really fast. And you can kind of ensure that you're covering all of those spaces of your code, your tests, and your documentation all together. Okay, so dependencies. Dependencies is a really big topic. And there are like split opinions on how much to use dependencies in your package. I know a lot of people are sort of aiming for dependency-free packages, which has pros and cons. I love base R. I've been using R for long enough, like before tidyverse, and so I'm pretty comfortable with base R. I use vapply over per most of the time. People make fun of me for it, but and I think that's great. Like using as much base as you can is good for sort of like most of your basic functionality. I don't recommend adding dplyr as a dependency if you're just using mutate to add a column, right? That's a very heavy dependency for a small benefit. But if you're doing something more complex in your package, if you're doing complex joins or grouped operations, then adding dplyr as a dependency is probably going to be worth it, because those things can be complicated. And I think the main thrust of it is try not to reinvent the wheel. It's tempting to say like, oh, I don't need a dependency. I can write my own function to do that. But your bespoke solution is probably not going to be as well engineered or well tested as a package that was created entirely to tackle that small problem that you're now including in your package. So there's a line, and that line is going to be in a different place for everybody, and depending on depending on your sort of like domain expertise, you're going to cross that line at different times. Like there's always going to be things like if you're writing a package for spatial analysis, you're going to use SF as a dependency, almost certainly. You're not going to start to rewrite that from scratch. So there's a place for them, and you just have to figure out where that line is for you. So if you decided you want to take on some dependencies, which you will eventually, there's some sort of different things to think about. One is like the type or the source of the dependency. So R comes with, there's base R, and then there's stats, utils, matrix. Those things come bundled with R. So using those is almost a no-brainer. It feels like using base R. There's really no cost. Is the dependency on CRAN? That's like good. There's some sign of stability there. It doesn't require any user action to get that dependency most of the time. If it's on Bioconductor or our universe, it's going to require user adding sort of additional repositories. So it's going to make it a little bit more complicated. So there's a sliding scale there. If it's a GitHub dependency, that's like sort of like extra scary, and you probably don't want to do that for something that you want people to go out and use sort of day to day. Sometimes your dependency is already fulfilled. So if you're using, I'm going to keep going back to tidyverse packages because everybody's familiar with them. If you've got dplyr as a dependency, and you want to use rlang, and you're like sort of struggling over that, you've got rlang for free because it's a dependency of dplyr. So adding it to your list of dependencies is not really increasing your dependency load in your package, because that dependency is already fulfilled by one of your prior dependencies. The weight of the dependency matters, weight in quotes. So like, is it a large, cumbersome package that's difficult to install, that's got like complicated system dependencies? I mentioned SF before. It's a heavy dependency, but if you're writing a spatial package, you're probably going to need it. Anything depending on R Java is definitely going to cause problems for a large majority of your users. So adding a dependency like that is you probably want to take a big pause before you do that. And then a big one is just sort of like, are there signals of how well it's maintained? How long has it been on CRAN? Take a look at the news files or the change logs to see if it's updated frequently. Is there lots of activity on GitHub? Does it have a lot of contributors? Those are good signs, right? Those are things that say like, this package is probably going to be around in a while. So I'm comfortable taking it on as a dependency. One thing is important to remember, that in like the very vast majority of cases, dev tools and use this should not be dependencies of your package. They're just the tools that we use to help build the package. But we don't generally use their package code, their code in the package itself. So I am slightly worried about time here, especially given our late start.
Well, we got a late start, so I use your judgment. How much time? I can be around a little bit past the hour, but for sure,
Sure.
given our late start, like we'll be a little flexible, whatever works for
Okay.
you.
Yeah, I'm sticking around. I say we go as long as is needed to answer all the questions and things. So you're good.
Okay, thanks. Okay, so another handy use this function, use package, that adds a dependency. You can do it manually, it's not hard, but this is like the less you have to leave via our console, the better. And so I use package all the time to add dependencies. And it gives us some nice tips. It says it adds, so if we use package fs, it's adding fs to the imports field and description. And you refer your functions with fs double : function. There are 3 places to list dependencies in your description file. Depends, imports, and suggests. Depends ensures that depends and imports both ensure that the package is installed when your package is installed. Depends is aggressive. Some say user hostile if it's not used correctly. because it attaches that dependency into the user's environment when your package is attached. So that can pollute their namespace, their global namespace, unintentionally. It's rarely needed or recommended to put a package in depends. Imports is the most common, and mainly what it does is it ensures that the package is installed when your package is installed, so that your package will work because it's got that dependency installed with it. Suggests has like sort of a larger range of reasons why you'd use it. It doesn't ensure installation automatically unless a user specifically asks for it. It's generally used by developers or rarely used functionality. I'm going to sort of, for the rest of what I'm talking about, we're going to talk about keeping your dependencies in the imports field in description file, because it's like the vast majority of time will be the case. Okay, so based on that assumption, we're going to go over 3 ways to use functions from another package. And I'm sort of from the most to least common and the most to least recommended. So the first one is to add the package to your imports section of your description file. And then whenever you're using functions from that package, you use the double colon namespace qualifier. And so that ends up with your description file having, so in this case, per listed in the import section. Within your function, you're going to have per : map. And when you run document, just your function is being exported. It gets exported to the namespace. So it doesn't, per doesn't show up in your namespace file. It's just in the description and in your package code. There's a few reasons why this is really good. For one, when you're reading the code, it's immediately clear where those functions are coming from, because they're prefaced by the package name, and it reduces the chances of name conflicts if there are other packages named similarly, functions named similarly. If you're using one or a few packages from functions from a package but use them a lot, you can import just those functions by using the import from Roxygen tag in your Roxygen comments. So you can see here, so we've still added it to the description file. In your function file, there's this @import from per map. And then that means we can use map in our functions without that namespace qualifier, without saying per : And then when we run document, our namespace file gets generated, and it has now this import from per map, saying that the per is now available inside your package namespace without that qualifier. And then the third way is to import the entire package by just a import statement. This is rare. It's useful when you're using a lot of functions from a package and using them frequently. So I think a lot of the tidyverse packages straight up import rlang because it's used so ubiquitously across their packages. And this ends up all of those functions are available to use without a namespace qualifier in your functions, and that package gets imported in your namespace. Okay, so just coming back to this workflow, I think we've covered all of this, so I'm going to go past this slide now. A README, everybody's package, especially if it's on GitHub, should have a README. And the only thing I want to say about this is so there's this use README RMD, which is really handy for creating your readme.rmd file. But sort of the productivity hack that I sort of embarrassingly lately discovered late is this build README function. And it's really handy because often if you want to just like click the knit button in your readme RMD file or type R markdown render, your current package may not be installed and it's needed to render the README. So this build README function actually goes to a temporary directory, installs your package there, builds the README with that temporarily installed version of the package and then renders the README. So this build README function is actually super handy. And I just wanted to highlight it there. Okay, I mentioned continuous integration briefly. And it is a software development practice where you regularly merge your changes into a central repository, and some automated processes run some checks. For us in practice, I'm going to talk about GitHub Actions that run our command check for us whenever we push. There's a bunch of different GitHub Actions that you can choose from with using the use GitHub Action function. Sort of the basic foundational level is using the check standard, and this sets up GitHub Actions in our package and in our GitHub repository to run our command check on Mac, Windows, and Linux, and on current, old, and development versions of R. And so this one is pretty magic, because you're just running this one function sets up like all this amazing infrastructure for you without you having to really know the details of it. It's actually kind of useful to run this once every 6 months or so, because the GitHub Actions get refreshed and you can just sort of grab the newest version. But basically, this is all you need to set up GitHub Actions so that you've got this continuous integration on your workflow. And basically what that does is sort of adds one more endpoint on our workflow, that when we push, we've been running check locally, hopefully, but when we push to GitHub Actions, we know that it's getting checked every time we push our code to GitHub. And we can be confident that our code's working, that our tests are getting run, and that the structure of our packages is being validated by our command check. Okay, so that's a whole lot of functions, and some of them you run once, some of them you run like relatively frequently, and then some of them you run really frequently. And so to me, the muscle memory is really useful if you build it on the right-hand side, this like run frequently. If you can get those keyboard shortcuts for load all, document, test, and check, and like put them on a sticky note, I think you'll find that sort of like your package development workflow really starts to develop. One function that I didn't mention, but is like the most magical thing in use this, is the use package down GitHub pages. And it basically takes your documentation and builds and publishes a package down site. So if you haven't seen a package down site before, you probably have. All those sort of like standard looking package documentation websites are built with package down and GitHub pages. And this function, literally one function call, does it all. And so it's very, very, very large bang for your buck with that one. And I guess the other one to mention now is rename files. It's a bit esoteric, but when we talked about having your files in your R directory mirror the naming of their files in your test directory, if you decide that you want to rename one, it's easy to forget the other. So you can use this rename files function, and if they're named the same already or named sort of like similarly already, it will rename both of them for you. So it's pretty handy for that. I don't use it often, but it is a useful thing. Okay, even though you said I could keep going, I do want to respect people's time, so I'll
And we do have some questions, so
yeah, for sure. Yeah. I'm
maybe
gonna make a
yeah,
quick advertisement for use this pull request helpers. They all start with PR underscore something, and they are designed to make pull requests as painless as possible. There's a great vignette on them, and they use this website. and they're really helpful because they have this like really nice consistent syntax. They do quite a lot for you, especially like trying to prevent you from shooting yourself in the foot with Git. So they're really, really handy. Take a while to get used to, but once you get used to them, they're really good. And I'm not going to go through that, and I'm not going to go through CRAN.
Just skip CRAN. We don't need to talk about CRAN.
Yeah.
It's no big deal. It's no big deal.
But none of these ideas that I'm talking about are my own, or very few of them. So this is just some really helpful resources. The R packages book, obviously, Happy Git with R by Jenny Bryan is an amazing resource for using Git. The package development cheat sheet, and this cool document that the Tidyverse team is building right now on sort of the design principles for writing packages. And that's it. Apologize for ripping through some of that.
No, we apologize again too about
no, it's
the
okay.
timing.
Yeah, it happens. It's all good.
Yeah, awesome. We do have a couple of interesting questions, I think, and
sure.
that we can have a little conversation about. One that came in over in the official Q&A was about when you have tests and you need data for your tests, what kind of approaches do you use to like you need to write a test that a function how it's behaving, how you need to.
Yeah.
What have you used? What do you recommend? What are some approaches you think are good?
Yeah, I have to look it up every time I do it because I don't do it frequently enough. But you can include data in your test directory. You want it to be small.
Yeah.
And you want it to be like not sensitive. And there's a function called test_file. I think is the one that helps sort of like you orient your test to find that file to run it. So that's one way to do it. And you can put anything, like you can put RDS files, you can put CSVs in your test directory. I think the key, and unless I'm missing the nuance of the question, one of the keys is to make it small.
Yeah.
So that your test can run fast. Because if your test runs slowly, I've got one package that I need to work on the tests for because the tests take forever. It just means you don't run them.
Yep.
And then you're in danger of breaking things because you're not running your tests. So small, and you can put test data in your test directory.
Yeah, so sometimes those kinds of things are called test fixtures. So if you're like looking for, trying to look up a blog post or to get more advice about that, you might look for that, like about test fixtures. So a lot of times when I need some data, I'll use something built in from R, like mtcars, or that I might, if I have built-in data in the package to use in examples, I'll use that same data in tests. And sometimes I inline things, like I'll inline creating a tiny data frame or a tiny string or something like that. Yeah, that's a great question.
Thanks, Julie.
So
caution against using generated data for tests because then you can have random failures that can frustrate you when you're trying to submit to CRAN.
Yes, very true. You don't want a lot of randomness in that data that you might use in a test. So another question that we have, Andy, is a lot of this focused on like uses, tests that. Have you experimented with any of the sort of alternative tools that exist in the R ecosystem? Things like Tiny Test, things like I'm familiar with Box. Some of these kind of tools that are you kind of address this with like dependencies in terms of your package. Have you thought about, or like what, when you're making decisions about what to use, have you thought about or tried out using some of these alternatives that are usually built to be, they're built with a priority of like being lighter weight.
Lightweight,
usually.
Yeah, I mean, I've definitely looked at them. To be honest, I haven't used them. My feeling is with the sort of, I mean, I don't hate to call them a standard, but it's kind of become a community standard, especially with like test that. Is that there's so much momentum behind it, I can not see it going away.
Yeah.
Even if it's, you can consider it heavyweight. There's just so much I don't think it's going to go away because there's so much momentum behind it. And B, there's so many resources out there to help you use it because so many people use it. And so it kind of becomes self-perpetuating. I mean, you can see that as a good or a bad thing, like, right, VHS versus Betamax for people who are as old as me. But, people coalesce behind the popular thing because everybody uses it and everyone knows how to use it.
Yeah.
So I honestly don't have any direct experience with those.
Yeah. No, that is actually, it says a lot. So I work now, I still do most of my work in R, but I also work in Python now too. And the fact that there is like the proportion of R packages that are set up the same way, the same kind of testing, the same way of building, the same way of making documentation, like it means you can contribute to other people's packages with a pretty low lift. And honestly, in the Python ecosystem, it is not like that. Like everyone, there's no like built-in documentation for Python packaging. So everyone does it like a different, I mean, that's sort of true what I just said. Anyway, everyone does it a different way. Everyone literally, like there's no equivalent of a description file. So there's all these different ways of doing it. And it's much worse. It's much worse. Like, because you can't be confident you can go to someone else's package and contribute to it. So there's a lot of, some people are uncomfortable with like a dominant, like a dominant way of doing things, but there's some real benefits to it as well.
Yeah, I think so too.
Yeah. Folks wanted to ask how you made these slides because of how beautiful they are, and I agree they're incredible.
Well, thank you. Honestly, they're just they're Keynote.
Just Keynote. Yeah, but I mean, they're incredible. They look very, 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 very good.
Thank you. If anybody, I'm sure the intersection is small. If anybody on the call did come to my workshop at PositConf, they will look familiar.
Gotcha. So one question that I think is interesting to talk about is the intersection of a description file and renv, an rm.lock, and when to use one versus the other for, say, an R package that you'd intend other people to use, or a data analysis project, or that type of thing. What kind of things have you run into with that?
Yeah, I mean, I don't think an RM, like using RM as part of a package, is necessarily thought of as good practice. Like, because the description file kind of does that work in a package environment. I know when you're setting up an analysis, sort of with a package structure, that's a different story. I don't know. My guess is that someone on the call has a better experience with RM than me. I've used it only a little bit.
Yeah, I think what you just said is right. I think like CRAN or any of the CRAN-like places, like our universe or whatever, they don't use rm.lock, like they use description. So it's really not that helpful to think about RN for package development. It also means, because of how RN works, like if someone's going to come and contribute to your package, if you put RN in it, that means it actually like forces that person in to RN, which is a bit of an uncomfortable move.
Yeah, I've experienced that.
Yeah.
It's not a trivial undertaking to like sort of grok the whole moving pieces of it.
Yeah. So I use RM the most for like Docker containers and deploying stuff, and it's great for that, but I actually don't use it. I don't use it at all for our package development, and I think it would be like not a great choice.
Yeah.
And I don't use it as much as for data analysis. I'll be more like, here's my main like library of things, and if I need to get exactly the versions that I'm using right now to a different place like Docker, like that's my favorite use of our end, actually.
No, that makes sense.
Yeah. Nice. I think these were great questions. I think we got most of them. Oh, do you know why I don't? The shortcut for check is Command Shift E. Do you know why E? I don't.
Well, I guess is like, so probably not C, because you don't want to accidentally Control C.
Yeah.
In places where you cancel running things or whatever, and I don't know.
Yeah, no, I don't either. Oh, there's one more I'm remembering now. Yeah, no, I don't think any of us know the answer to that. So someone asked about a project for R called Fusion that Think R does, which is like you take a notebook and then it generates a package. And of course, there's a very similar thing in Python that's called NBDev that is largely based on like Jupyter and also Quarto, where you write in a packet. You write in like a notebook, R Markdown or Quarto kind of thing, and then the software extracts it out and makes packages. I think it's been interesting to see these tools kind of come up and both in Python and R. And I have never used one of them. I've never used one of them, and I'm honestly like I don't quite grasp the value like why, but I'm wondering if you've heard about people using them, or if you feel like it could be interesting for like a beginner, like getting their first sort of package structure on. What have you thought or looked at any of those?
I mean, I've seen Fusion a little bit, and my first thought was the same as yours. It's like I don't really get why. I'm not a big notebook person, regardless. Um, but I think you're probably right. Like for a beginner, right? Like, is if you know how to write packages, I mean, sorry, write functions, and you can sort of like write some functions in a notebook, um, and then convert that into the package structure. Maybe you can like more immediately see like, oh, this is how my functions that I was writing fit into a package structure without having to build it from the ground up.
Yeah,
I
yeah,
think so like that would be my guess is like where like maybe bootstrapping a package right from some existing functions would be a good use case.
yeah,
I like honestly with like create package use R, it's not a long journey either.
yeah, yeah.
Um, yeah.
Yeah, yeah. Awesome. Okay, I think we hit the most of the questions. There were a few other ones that people typed answers to, which we thank you so much for those of you who did that, including Andrew, of course. So, everyone, thank you again so much for your time here. You can join the meetup group if you. I think you will have had to join this, so you'll get notifications of our next meetings. As a reminder, we do kind of alternate in-person meetings here in the Salt Lake area that are like networking based for people to say hello in person with these online virtual talks, which seems to work best for people. So we're really glad that you all came here. Thank you for your time. You can find this on you can find us on YouTube. You can find us on a Meetup, and we are so glad that you all came. And once again, thank you so much to Andy for presenting this, including your very beautiful slides.
Oh, thanks so much for having me. It was really fun.
Yeah, thank you.
Thanks for the great question.
All right. We will get our